Hello, this video should help you understand the basics, or the basic concepts at least, of stoichiometry. So stoichiometry is a weird word. It comes from two different Greek words. Metry, which means to measure, like a meter stick measures things, and stoichio, which means element. So stoichiometry is measuring the elements. Basically, stoichiometry is the study of the relationships between different chemicals involved in a chemical reaction. To explain it, I'll use a metaphor. It's sort of helpful. This is a recipe for a cake. You add 8 ounces of butter, 3/4 of a cup of cocoa powder, etc., 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 and then you put them all together, you put it in the oven, and you get a cake. This specifically is a chocolate bundt cake. It looks really good to me, at least. So, one important thing about making this cake is that you add the right amounts of the right ingredients. You don't mess it up. For example, if you have 4 large eggs and a half cup of milk, this is going to give you a different result. So like this gives you something nice, this cake. But if you added, for example, 4 cups of milk, and instead 1/2 of an egg, you would get something else. You would get a soggy mess. Maybe instead of adding 1 teaspoon of salt and 8 ounces of butter, you flip it, right? You add 8 ounces of salt and then 1 teaspoon of butter. You're not going to get a cake. You're going to get a mess. To get this cake, the thing that you want, it's very important that you add these specific ingredients, and not only do you have to add these ingredients, but you have to add them in the right amounts. Now, I'm going to teach you about chemical reactions, and making a cake is a chemical reaction. It's just a very hopelessly complicated one, involving hundreds and hundreds of different molecules and tons of steps. This is way beyond our level of expertise right now. But this basic principle, we're going to apply to something simple. Like, for example, the production of ammonia. So this is ammonia right here, NH3. And the recipe for ammonia is pretty simple. You add 1 nitrogen molecule and 3 hydrogen, so 1 nitrogen gas molecule, which is N2, and then 3 hydrogen gas molecules, which is H2. So that'll give you 2 molecules of ammonia, which is what you want to make. We are going to figure out how to go from here to here, or rather to figure out exactly how much of this you need to add in order to get maybe 4 pounds of ammonia. So it's understanding the relationships between the ingredients and the products you make. The ratios are important because if you add 8 ounces of salt, or 8 ounces of butter and 1 teaspoon of salt, that gives you something very different than if you flip it, right? So we want to make specifically this chemical. We're going to learn about what we need to add, like to put in the pot, to make it. We use 3 facts to do this, and only 3. So using these 3 facts, we can do stoichiometry problems to figure out how much of each element we have to put in a beaker or a test tube to get the desired amount of product. We use this fact, which is true of literally everything ever. 1 mole is equal to 602 sectillion particles. This fact, which is that 1 mole of a particular substance is always going to be the same mass. And I put this in blue so that you remember the molar mass. This is specific to each individual chemical, but for an individual chemical, it's unchanging. So for example, if I wanted to talk about water, H2O, I would have to use the molar mass of water, which is 18. But if I wanted to use a different chemical, maybe I wanted to use like N2, well, this is still true. 1 mole is equal to the molar mass, but the molar mass of N2 is no longer 18, it's 28. So this is blue to remind you that you have to calculate it for a specific chemical, but it's the same for each one. And then you need your recipe down here, right? This is a chemical equation, which tells you the specific ratio you need of the reactants to make the products. And this is a generic one. Some number of substance 1 plus some number of substance 2 gives you some number of substance 3. And it's the recipe. In the example I did before, you have 3 hydrogens and 1 nitrogen. Well, 3 hydrogen gas plus 1 nitrogen gas gives you 2 molecules of ammonia. So this right here is sort of the key to stoichiometry, and it's just like the cake recipe is up here. It tells you what you need to add and what the amounts need to be to get the desired product. Maybe this is a little bit vague now because we're not doing any sort of concrete problems, but I'm going to do that in a later video. So what you should remember is that stoichiometry is the study of the relationship of products to reactants. When we do stoichiometry, it's like we're analyzing a recipe to make a cake. Except this is too complicated. We're really analyzing a recipe to make ammonia or something simple, because those are 1 step. And that the only things you need to do stoichiometry, the only 3 facts you need are this, the definition of a mole, this, the ability to calculate the molar mass of a chemical, and this, some chemical equation or recipe that you're analyzing.